Hello everyone and welcome to another math video. I'm Professor Diwa, and in this video I'll be going over absolute value equations. Our objectives for this video are to solve absolute value equations. Alright, so let's get started. First, we're going to go over solving absolute value equations of the form absolute value of capital X equals A. Note that the capital X inside the absolute value can represent a single variable like x, or it could be any variable expression like 1/2 x plus 1 or x minus 3, and so on. Alright, so when solving an absolute value equation, there are three different rules that we need to follow. The first rule states if a is a positive number, then the absolute value of capital X equals a is equivalent to capital X equals a or capital X equals negative a. The second rule states, if a is 0, then the absolute value of capital X equals 0 is equivalent to capital X equals 0. The third rule states, if a is a negative number, then the absolute value of capital X equals a has no solution. So when you're working with absolute value equations, the first thing you need to do is determine which rule you need to apply, and then solve it accordingly. Here we have example number 1, where we need to solve each of the absolute value equations. For part A, we have that the absolute value of x is equal to 4. The first thing we need to do here is determine which of the three rules we need to apply. So, because the absolute value of x is equal to a positive number 4, we know that we apply rule number 1, where if we have the absolute value of x is equal to a positive number a, this is equivalent to x equals a or x equals negative a. So for this problem, the solution would be x equals 4 or x equals negative 4. And then we write our final solution using set notation. So I have curly brackets and then negative 4 comma 4 inside the curly brackets. Next, I want to go over the reason why we have two different solutions for this problem. So the reason why we have two different solutions is because the absolute value represents a number's distance away from 0. For part A, we're looking for a number whose distance away from 0 is 4 spaces. So here I have a number line, and you can see here that at 0, if I count 4 spaces to the left, we have negative 4. And you can see here negative 4 is 4 spaces away from 0. And then also, if we go towards the right, we have 4. You can see here 4 is also 4 spaces away from 0. So that's the reason why we have two different solutions here. Moving on to part B, we have the absolute value of x equals 0. For this problem, we need to apply rule number 2. Since the absolute value of x is equal to 0, this is equivalent to x equals 0. So this means we only have one solution, x equals 0. We write our final answer with curly brackets and 0 inside. Now the reason why we only have one solution is because if you take a look at this number line I have here, 0 would be the only number whose distance away from 0 is 0 spaces. So there's only one solution of 0. Moving on to part C, we have the absolute value of x equals negative 3. Now for this problem, we apply rule number 3, where if a is a negative number, then the absolute value of x equals a has no solution. So for the absolute value of x equaling negative 3, this has no solution. Next, we write our final answer using curly brackets with nothing inside, or we could use a circle with a diagonal line going across. Now the reason why this has no solution is because you can see here on my number line, I marked off 0 and two possible answers. We have negative 3 and positive 3. Negative 3 and positive 3 have a distance away from 0, which is positive 3 spaces away. Part C is asking us, what number has a distance away from 0 of negative 3 spaces? Distance is always a positive value. That's the reason why we have no solution for part C. Moving on to example number 2, here we need to solve the following absolute value equations. For part A, we have the absolute value of 2x plus 5, and outside of the absolute value, we have minus 5 equals 8. Now before we can apply any of the absolute value rules, we need to first isolate the absolute value all by itself on one side of the equation. So the first thing I'm going to do is get rid of the minus 5 by adding 5 to both sides of the equation. Simplifying the left-hand side, we have minus 5 plus 5 cancels out, and then we bring down the absolute value of 2x plus 5. On the right-hand side, we have 8 plus 5 is 13. So the result is the absolute value of 2x plus 5, and then we have equals 13. So from here, we could apply our absolute value rules. Since our absolute value is equal to a positive number, this would be rule number 1. So we would rewrite this as 2x plus 5 equals 13, or 2x plus 5 equals negative 13. And then from here, we go ahead and solve each of the equations, and then we'll have two solutions. Starting with the 2x plus 5 equals 13, we solve for x by getting rid of the plus 5. To get rid of the plus 5, we subtract 5 from both sides of the equation. Simplifying the left-hand side, plus 5 minus 5 cancels out. We bring down the 2x, and on the right-hand side, 13 minus 5 is 8, so we have 2x equals 8. From here, we get rid of the 2 by dividing it out on both sides of the equation. So we get 2x divided by 2 equals 8 divided by 2. Simplifying the left-hand side, 2x divided by 2 cancels out and leaves us with an x. On the right-hand side, 8 divided by 2 is 4, so our result is x equals 4. Solving the second equation, 2x plus 5 equals negative 13, we first get rid of the plus 5 by subtracting 5 on both sides. Simplifying the left-hand side, we have plus 5 minus 5 cancels out. We bring down the 2x. And then on the right-hand side, minus 13 minus 5 gives us negative 18. So we have 2x equals negative 18. Next, we get rid of the 2 by dividing both sides by 2. So we have 2x divided by 2 equals negative 18 divided by 2. Next, we simplify the left-hand side. 2x divided by 2 is x. And on the right-hand side, negative 18 divided by 2 is negative 9. So the result is x equals negative 9. All right, so our final answer would be written in set notation. So we have curly brackets, and on the inside, we write negative 9 comma 4. Moving on to part B, we have 2 times the absolute value of 5x. Outside of the absolute value, we have minus 3 equals 37. Again, we need to isolate the absolute value first before applying any of the absolute value rules. So first, I'll get rid of the minus 3 by adding 3 to both sides of the equation. On the left-hand side, we get minus 3 plus 3 cancels out, and we bring down the 2 times the absolute value of 5x. On the right-hand side, we have 37 plus 3 is 40, so the result is 2 times the absolute value of 5x equals 40. Next, we need to get rid of the 2 multiplying the absolute value. To get rid of the 2, we just divide both sides by 2. So we have 2 times the absolute value of 5x divided by 2 equals 40 divided by 2. Simplifying the left-hand side, the 2 on top cancels out with the 2 on bottom, and we bring down the absolute value of 5x. On the right-hand side, 40 divided by 2 gives us 20. The result is the absolute value of 5x equals 20. From here, we could go ahead and apply the first absolute value rule. So we rewrite the absolute value of 5x equals 20 as 5x equals 20, or 5x equals negative 20. To solve 5x equals 20, we divide both sides by 5, and we get 5x divided by 5 equals 20 divided by 5. Simplifying the left-hand side, we have 5x divided by 5 is just x, and on the right-hand side, 20 divided by 5 is just 4. The result is x equals 4. Next, we could go ahead and solve 5x equals negative 20. We get rid of the 5 in front of the x by dividing both sides by 5. We get 5x divided by 5 equals negative 20 divided by 5. Simplifying the left-hand side, 5x divided by 5 is just x. Simplifying the right-hand side, negative 20 divided by 5 is negative 4. The result is x equals negative 4. So you can see we have two solutions here, 4 and negative 4. And we write our final answer using set notation. So I have curly brackets. Inside the curly brackets, I wrote negative 4 comma 4. Next, we have a practice problem for you to solve. For part A, we have the absolute value of 2x minus 1. Outside the absolute value, we have plus 3 equals 12. For part B, we have 2 times the absolute value of x plus 3. Outside the absolute value, we have plus 1 equals negative 14. So go ahead and pause the video and try out these problems. Afterwards, go ahead and check back with the video to see the solutions. Okay, so let's go over the solutions for part A. The first thing we need to do here is isolate the absolute value. So I'm going to get rid of the positive 3 by subtracting 3 from both sides. Simplifying the left-hand side, plus 3 minus 3 cancels out, and we bring down the absolute value of 2x minus 1. On the right-hand side, 12 minus 3 is 9. So the result is the absolute value of 2x minus 1 equals 9. From here, we can apply the first absolute value rule. So we rewrite the absolute value equation as 2x minus 1 equals 9, or 2x minus 1 equals negative 9. First, we solve the 2x minus 1 equals 9 for x. We get rid of the minus 1 by adding 1 to both sides of the equation. On the left-hand side, the minus 1 plus 1 will cancel out. We bring down the 2x. On the right-hand side, 9 plus 1 is 10, so we have 2x equals 10. From here, we get rid of the 2 in front of the x. We just divide both sides by 2. We get 2x divided by 2 equals 10 divided by 2. Simplifying the left-hand side, 2x divided by 2 is just x. On the right-hand side, 10 divided by 2 is just 5. So the result is x equals 5. Now we solve the 2x minus 1 equals negative 9 for x. We get rid of the minus 1 by adding 1 to both sides of the equation. On the left-hand side, the minus 1 and the plus 1 cancels out. We bring down the 2x. On the right-hand side, we have minus 9 plus 1 is negative 8. So the result is 2x equals negative 8. From here, we get rid of the 2 by dividing both sides by 2. So we get 2x divided by 2 equals negative 8 divided by 2. Simplifying the left-hand side, 2x divided by 2 is x. And the right-hand side, we have negative 8 divided by 2 is negative 4. The result is x equals negative 4. So we have two solutions, negative 4 and 5, and we write our answer with set notation. So we have curly bracket, negative 4, comma 5, close curly bracket. Moving on to part B, we have 2 times the absolute value, x plus 3. Outside the absolute value, we have plus 1 equals negative 14. The first thing we need to do before applying a rule is isolate the absolute value by itself. So first we need to get rid of the plus 1 by subtracting 1 from both sides of the equation. Simplifying the left-hand side, the plus 1 minus 1 cancels out, and we bring down the 2 times the absolute value of x plus 3. On the right-hand side, the minus 14 and minus 1 combine together to give us minus 15. So we have 2 times the absolute value of x plus 3 equals negative 15. The next step is getting rid of the 2 in front of the absolute value. We just divide both sides by 2. We get 2 times the absolute value of x plus 3, all divided by 2, equals negative 15 divided by 2. Simplifying the left-hand side, 2 times the absolute value of x plus 3 divided by 2 simplifies to the absolute value of x plus 3. On the right-hand side, negative 15 divided by 2 is negative 7.5. From here, we can apply rule number 3. Since our absolute value is equal to a negative number, this means that we have no solution. So our final answer, we write a set of curly brackets with nothing inside, or you could write a circle with a diagonal line going through it. Next, we have example number 3, where we need to solve the absolute value of x over 2 minus 1 equals 11. Since the absolute value is equal to a positive number, we can apply our first absolute value rule and rewrite the equation as x over 2 minus 1 equals 11, or x over 2 minus 1 equals negative 11. Solving the first equation, we get rid of the minus 1 by adding 1 to both sides of the equation. So on the right-hand side, the minus 1 and the plus 1 will cancel out. We bring down the x over 2, and on the right-hand side, we have 11 plus 1 is 12. So the result is x over 2 equals 12. The next step is getting rid of the 2 underneath the x. Since the 2 is dividing the x, we just need to multiply both sides of the equation by 2. So we have 2 times x over 2 equals 2 times 12. Simplifying the left-hand side, the 2's will cancel out and leave us an x. And on the right-hand side, we have 2 times 12, which is 24. So the result is x equals 24. Now we solve the other equation. To get rid of the minus 1, we just add 1 to both sides. On the left-hand side, we have minus 1 plus 1 cancels out, and then we bring down the x over 2. On the right-hand side, we have minus 11 plus 1 is negative 10. So the result is x over 2 equals negative 10. From here, we get rid of the 2 underneath the x by multiplying both sides of the equation by 2. So we have 2 times x over 2 equals 2 times negative 10. Simplifying the left-hand side, the 2's will cancel out and give us an x. On the right-hand side, 2 times negative 10 is negative 20. So the result is x equals negative 20. This means we have two solutions, negative 20 and 24. We write our final answer using set notation. So I have curly bracket, negative 20, comma 24, close curly bracket. Next, we have another practice problem for you to solve. For part A, we have the absolute value of x over 5 plus 1 equals 15. For part B, we have the absolute value of the fraction 3x plus 1 divided by 2 equals negative 2. So go ahead and pause the video, take your time working out these problems, and then check back with the video when you finish. Alright, so let's go over part A. For part A, we have that the absolute value is equal to 15, which is a positive number. So we could apply the first absolute value rule. We could rewrite this absolute value as x over 5 plus 1 equals 15, or x over 5 plus 1 equals negative 15. From here, we could go ahead and solve the first equation by getting rid of the positive 1. We just subtract 1 from both sides of the equation. On the left-hand side, the plus 1 minus 1 cancels out, and we bring down the x over 5. On the right-hand side, we have 15 minus 1 is 14. The result is x over 5 equals 14. From here, we get rid of the 5 underneath the x by multiplying both sides of the equation by 5. We get 5 times x over 5 equals 5 times 14. Simplifying the left-hand side, 5 times x over 5 is just going to give us x. And on the right-hand side, 5 times 14 is 70. So we get x equals 70. Next, we go ahead and solve the second equation. So we get rid of the plus 1 by subtracting 1 from both sides of the equation. So on the left-hand side, plus 1 minus 1 cancels out, and then we bring down the x over 5. On the right-hand side, minus 15 minus 1 is negative 16. The result is x over 5 equals negative 16. Next, we get rid of the 5 on the denominator by multiplying both sides of the equation by 5. We get 5 times x over 5 equals 5 times negative 16. Simplifying the left-hand side, the 5's cancel out and we get an x. On the right-hand side, we have 5 times negative 16 is negative 80. The result is x equals negative 80. Our final solution we write with curly brackets, and we have inside the curly brackets negative 80, comma 70. Moving on to part B, we have the absolute value of 3x plus 1 divided by 2 equals negative 2. Since the absolute value is equal to negative 2, we apply the third absolute value rule. This means that this absolute value equation has no solution. So for the final answer, you can write a set of empty curly brackets, or you could put a circle with a diagonal line going through it. Next, we're going to go over another rule, which we'll use for solving absolute value equations of the form absolute value of capital X equals absolute value of capital Y. This rule states the absolute value of capital X equals absolute value of capital Y is equivalent to capital X equals capital Y or capital X equals negative capital Y. In the next example, we'll go over how to apply this rule. In example number 4, we need to solve the absolute value of 2x minus 3 equals the absolute value of x plus 5. Since we have two absolute values equaling each other, we could apply the previous rule we just went over. So we could rewrite these absolute values as 2x minus 3 equals x plus 5, or 2x minus 3 equals negative parentheses x plus 5 close parentheses. Notice that we needed to subtract the entire second part of the equation in order to apply the rule correctly. Starting with the first equation, to solve for x, I did two steps at once. I got rid of the minus 3 by adding 3 to both sides of the equation. I also got rid of the x by subtracting x from both sides of the equation. Simplifying the left-hand side, 2x minus x will be x. Minus 3 plus 3 cancels out. On the right-hand side, x minus x cancels out, and 5 plus 3 is 8. So the result is x equals 8. Moving on to the second equation, the first thing I need to do here is distribute the negative inside the parentheses to the x and the plus 5. When we do the distribution, I get negative x minus 5. And then on the left-hand side, I brought down the 2x minus 3. So I have 2x minus 3 equals negative x minus 5. Next, I did two steps at once. I got rid of the minus x by adding x to both sides, and I got rid of the minus 3 by adding 3 to both sides. Simplifying the left-hand side, I have 2x plus x is 3x. Minus 3 plus 3 cancels out. On the right-hand side, minus x plus x cancels out. Minus 5 plus 3 gives me negative 2. So the result is 3x equals negative 2. Next, I need to get rid of the 3 in front of the x. We do this just by dividing both sides by 3. So I get 3x divided by 3 equals negative 2 divided by 3. Simplifying the left-hand side, 3x divided by 3 is x. And on the right-hand side, negative 2 divided by 3 stays the same. So the result is x equals negative 2/3. So we have two solutions, negative 2/3 and 8. And we write out our answer using set notation. So I have curly bracket, negative 2/3, comma 8, close curly bracket. Next, we have another practice problem. Here you need to solve the absolute value of x plus 4 equals absolute value of 2x minus 7. So go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Okay, so let's go over the solutions. First thing we do is rewrite the absolute value equation as x plus 4 equals 2x minus 7, or x plus 4 equals negative parentheses 2x minus 7 close parentheses. Starting with the first equation, we solve for x by doing two steps at once. We get rid of x by subtracting x from both sides of the equation, and we get rid of the minus 7 by adding 7 to both sides. Simplifying the left-hand side, x minus x cancels out. Plus 4 plus 7 gives us 11. On the right-hand side, we have 2x minus x gives us x. Minus 7 plus 7 will cancel out. So the result is 11 equals x, or we could just write this as x equals 11. Moving on to the second equation, first step is distributing the negative inside the parentheses to the 2x and the minus 7. We get negative 2x plus 7. On the right-hand side, we bring down the x plus 4. So we get x plus 4 equals negative 2x plus 7. Next, we do two steps at once. I get rid of the x by subtracting x from both sides of the equation, and I get rid of the plus 7 by subtracting 7 from both sides. Starting with the left-hand side, x minus x cancels out. Plus 4 minus 7 gives us negative 3. On the right-hand side, negative 2x minus x is negative 3x, and the plus 7 minus 7 cancels out. So the result is negative 3 equals negative 3x. Next step is getting rid of the negative 3 in front of the x. So we just divide both sides of the equation by negative 3. We get negative 3 divided by negative 3 equals negative 3x divided by negative 3. Simplifying the left-hand side, negative 3 divided by negative 3 is 1. And on the right-hand side, negative 3x divided by negative 3 is positive x. So the result is 1 equals x. Or you could write it as x equals 1. So we have two solutions. We have 1 and 11. And we write our final answer using set notation. So we have a set of curly brackets. And on the inside, we write 1 comma 11. Alright, so this is the end of our video. Thank you for watching. I'm Professor Diwa, and I'll see you again in the next one.